All right, we won't get into where these formulas come from exactly, but uh, I will make a correlation that remember area of any triangle is half the base times the height, right? So any random triangle where the height is that perpendicular, right? If I'm referring to this as the base, the height is always met at a 90, and we take half of that. In the Law of Science video, I talked about how we can solve for h, and we got some sort of form of this here, right? Sine of a times some other side. And that's really where it comes from, half the base and then times the height, which if when we solve for height, we get um, right from a right triangle, and I drop that, I use sine. So, alrighty. So pretty easy to see. And I only wrote one here, but just like the law of cosines formula, it's pretty easy to fill in the others, and I meant to leave it blank to show it. So if I know the angle capital A, then I have to know the lowercase bc. Okay, so I know one of each piece. And remember that um, capital A we often refer to as alpha. So in our very first problem that I wrote over here on the left, I am given lowercase b, lowercase c, and alpha. So to find area, I just plug all that information provided directly into that formula times 11, which is b, times 28, which is c, times sine a, or alpha, sine 28. Right? And using a calculator on that, you get about 20.7, because I mean that is all directly, like I can't do sine 28 without a calculator, right? Right? So get about 20.7. What is very weird, and this is common for almost every text I have seen, is all of this stuff where we're doing areas unitless, right? Like I have no idea what units we're talking about. So I am doing area. I would include square units, whatever unit we might be in, right? That is area. Okay. Now, the next two, you're just given some random triangle here. No mention of sides, right? No mention of letters, I should say. So we'll just call it whatever letter, just so I get a visual. If this is capital A or alpha, right, then this is lowercase a. And if this is capital B or beta, then this is lowercase b. And then capital C, lowercase c, which I know neither of those two, right? I don't know either C. Now that's a problem, because in that formula I need one of each. So how do we proceed? Now, even if we had the other two, we'll go ahead and write them. Okay, if I have lowercase b and c in big A, I could use the first one. But if I have lowercase a and b, then I would need capital C. And if I have lowercase, so the sides, when I say lowercase, right? The sides A and C, then I need angle B. Well, looking what I have lowercase a, lowercase b, and then capital A. That doesn't fit any of those three. Point is, you may need to do a little bit of work in order to proceed with the formula. Okay. If you drew a picture of any of those three, you will notice that what is given is always a side angle side. So if that helps to use this top formula, I need side angle side. Okay, Heron's formula we'll discuss here in a second, but Heron's, I will say that notice little a, little b, little c, that's all that shows up, and this little s, which uses little a, b, and c, that's when you have side, side, side. Okay, so that's out too. That's out for this first one, though it will work. For this one, I have side, side, side for the third example, right? Okay. Well, if I had big C going back to this example, sorry for jumping. If I had big C, I could use the second one, right? Because I have lowercase a, lowercase b. I need big C, though. So we could do law of sines, I believe. Let's double check. Remember, law of sines, we have A, S, S in order. So it's one of the bad ones that this could possibly not be a triangle. Then we would stuck. If it's not a triangle, we can't find area. The other thing is, because I gave you a drawing, and remember, a triangle with ASS could have two possible triangles. We do have somewhat of a visual for this angle here, right? Because it could be obtuse or it could be acute based on our results, but I drew it out for you, and I know it's an obtuse angle. All right, so we have some groundwork to do. Let's do law of sines. I know I want big C, but I don't have little c, right? So I can't proceed with this with two unknowns. So we'll have to get C last. So I do have little b, so I'm going to do sine b over b. Whoop, let's fill in what we know. Over little b, which is 25, equals sine A sine 40 over 18. So multiply by 25 and do sine inverse. So b is sine inverse of all that stuff, right? Of 25 over 18 times sine 40. And you get approximately 63.22. Okay, I'll use that if there is no other option, right? If that is definitely one triangle, then I will use that. But we got to check the alternative. So, or, remember, subtract it from 180. And we would get 116.78. Okay, would that be possible? Yes, because angle A is a 40, right? So that would make 156. So angle C then would be 180 minus 156.78, since that is A and B combined, right? The 40 and the 116. So I'm using this one because the picture that was drawn, it looks obtuse. So if there were two possibilities, I want to use that one. If it looked closer to 63, the acute angle here, then I would use that one. All right, so C, we get, what, 23.22. All right, now I have what I need to do the formula. I have big C, little a, little b. So we're going to use that second one. I'll change colors here. The area, so not A. When I say A here, I'm actually talking about the area of the triangle, right? Area is 1/2 A times B, 18 times 25 times sine of 23.22 degrees. And that is all in a calculator, and you get about 88.7-ish square units. Okay, since we're doing area. Cool. Alrighty, so in geometry, we always needed that height. Without redrawing a triangle, we're finding the height just indirectly. Okay, we're using the formulas that were given. One more example. So how do you use how to use Heron's formula? So the first thing we need is this little s. I don't think it stands for anything special. Not that I recall. It's just, I mean, this textbook calls it a semi-perimeter, but I don't know that it stands for anything in particular. We won't show where this formula came from. We'll just show how to use it. So the first step, we need s. It's pretty straightforward. To get s, you take all three sides, add them up, so find perimeter, right, and divide by 2. 50 plus 36 plus 22 would be my perimeter. Divide that by 2. So we get, what was that, 86, 88, 108 divided by 2. We get 54. Okay. So S is 54. Now we're going to need a calculator because I'm not multiplying this all out. But the formula says, let's switch colors, to take the square root of S, 54, multiplied by S minus A. So I'm going to write this out, but usually I just do this step in my head. 54 minus A. It doesn't matter which one you call A, B, and C. Right, I'll just call this one A, B, C. It really doesn't matter. 50, 54 minus 36, 54 minus 22. Okay, like I said, usually those steps I just do in my head though. So the area, not big A, not angle A, but the area of the triangle is square root. We'll just take our calculator and do 54 times 4 times 18 times 32 and square root that all. And you get about 352.73. Again, we're doing area, so square units. All right. So again, we didn't do half the base times the height. If I know all three sides, side, I can also find the area of a triangle.